And we're live. Welcome, everyone. Thank you for joining our Design Systems Community Berlin May Meetup. I'm Angie, part of the organizing team, together with Olga and Vic, who are here with me in the stream, and our two speakers for the meetup, Sage and Boris. Patricia and Sarah are also part of our organizing team. And in this slide, you can find all of our Twitter handles, just in case you want to reach out to us or be part of the community or the organizing team, as well as if you're interested in giving a talk. Next, we want to talk a little bit about our code of conduct. And all of our events, all of our meetups are supported by our code of conduct. So please respect each other, keep it legal, play nice, uphold the conduct and our values, and protect your privacy. And I also want to talk a little bit about our values. So, well, we think accessibility isn't a trend, but a foundation for everyone's design work. We advocate for diversity and inclusivity. We're allies to marginalized and underrepresented groups. Community comes first, and we're investing our time and effort here because we believe that we can build something good together. We're putting people at the center of our work. We prioritize teamwork opposed to individuality. We bridge diverse domains and encouraging an ongoing dialogue between disciplines. And we're here to have fun. So before I wrap up, please comment in the comment section below where you're following us from, and feel free to comment throughout the whole event, chat with us. And now I'll hand over to Olga, who'll talk a little bit about our speakers and their talks today.
Thank you so much. Tonight we have a really exciting lineup. First, we will hear a little bit from Sage about how is it to build a menu component. And then next up, we will hear from Boris about the AWS Design System 4 years later. Now, you might be wondering how to ask questions during the talk. At any point in time during the talk, feel free to go to Slido using this QR code at the top or the link and post your questions there. We will not be interrupting the speakers. We will be asking all of those questions at a later point in time in a short Q&A session. But already, if you have a question right now, feel free to post it right there. Now, with that, I don't want to delay this any longer. Everyone is really excited to hear from Sage. Sage, go ahead. I hand the mic over to you.
Awesome. Thank you, Olga. Okay, so before I get started, I just want to say that I'm really excited to be here. Thank you so much for having me. I really can't wait to share like all the wealth of knowledge and everything I've sort of prepared for you guys. So just sit back, relax, and enjoy my talk. I'm happy to answer questions at the end as well.
Please feel free to also share your screen with us when you are ready. And I'll put everyone out of the stream.
Okay, I think I'm good to go. Awesome. So everyone, thank you so much for joining the talk today. I'm going to be talking about how to build an accessible menu component. I just want to gather all the learnings I've had for the past 2 to 3 years maintaining and building Chakra UI. So just do a quick intro just to get started. My name is Segun Adebayo. I like to be called Sage. Obviously, just because I'm a Naruto fan. I love animes a lot, so that's where I picked the name from. I'm currently a software engineer at Scribe.ai. I'm born in Nigeria, and I'm based in Dubai. That's where I work from. So when I introduce myself, I like to say that I solve problems for a living, and I also like to work in public. And one of my most common or most recent work is Chakra UI, an open source React component library that helps you build your website or your product with speed. All right, I've been a UI designer for close to 4 years, and I had to sort of like switch over after lots of like frustration, like working with engineers. I'm like, okay, I think it's time for me to learn this stuff myself. And I sort of delved into like the world of design systems and UI engineering. And I think it's been like a huge pleasure so far, being in this field. All right, I always like to celebrate each time I give a talk. So one of the most recent achievement is the fact that Chakra UI, the open source like React component library, was nominated as the most impactful project to the community last year, and we're hoping it will remain so this year anyway. And like so far, the key stats that we have is it's a very growing community. People are out there using Chakra UI, and I'm so excited that I have the privilege to share my knowledge and learnings with you today. All right. So before I go too far, I just want to quickly set a timer for myself because I'm pretty conscious of time. I like to talk a lot, so I like to time myself as well. Okay, cool. So a few things I'll be talking about today is I'm going to sort of walk through the menu design, interface design, which is more of like the design stuff, as the UI design of a menu. And I think it's pretty important to be able to like walk from a design of a menu and then work your way backwards into the code. Then I'll quickly run through like common menu design patterns that I've learned over the years. And we'll go through a couple of like open source many component APIs that are out there. I mean, take a look at the considerations. What I think about them, again, this is not exactly what I think about them, will mostly be just a recommendation on what I think. It does not mean that's the right or the wrong way, but then we'll just like use that as a source of learning. All right, and then we'll take a look at some accessibility considerations for menus, and we'll do some quick intro to state machines, because one of the things that I've been trying to learn a lot lately is about state machines and how to model a component logic in a way that's like fairly simple and easy to understand, and also easy to visualize. And hopefully, I hope like the God of life coding is happy with me today. I'd love to do like a quick walkthrough of how to build a menu component live with you here, and we'll build a simple menu state machine together. All right, so what you see is like there are really no much slides in this talk. I just want to be as practical as possible and show you like all my stuff in a very familiar environment, Code Sandbox. I'm sure you're pretty used to it. All right, so let's dig deep into like what my talk is about. Okay, so a common question I get a lot, especially from a design system perspective, when you hear the term menu component, there are different thoughts that comes to mind. Are you talking about like a drop-down menu, or are you talking about a select menu, or are you talking about a navigation menu? So it's pretty important to sort of know the right terminology and definition for this component that we talk about. Right, so the way I like to describe a menu is a widget that enables users to select from a list of options or command. Right, so I'm live here in Code Sandbox, and if you sort of like go all the way to the right, this is my profile here, and you can see this overflow menu right here, and I click on that. So this sort of presents to me what is commonly known as a menu, but then there are two types of menus. There's like the navigation menu, which typically means a menu of links, which means like when you click on a menu item, it takes you to a certain place in the app or a certain link on the website. Right, so that's sort of like what this is here. And there's also another category of links, which is called like an action menu. Typically, what that means is a menu of actions, right? So if you take your mouse again, Code Sandbox has a little overflow menu here again, and then you can see here that these are not navigation links. This is not a navigation menu. These are menus that take specific actions, right? And most of the time, these actions usually come with some sort of shortcut or command. As you can see here, Control K or Command K, to do like a couple of actions in Code Sandbox. So that's typically what a menu widget, looks like. And then when we come to the design part of a menu widget, these are like two simple designs. I went into Dribble, just did some quick search. I just pulled that out so that we can also see something visual about like what a menu could look like. I'm sure we are all familiar with this, but I would like to not assume and sort of show you a visual of what a menu pattern looks like. So it's typically a couple of actions or a couple of links. A user can click a button to trigger that, and then they can sort of like overrun or use their keyboard to navigate through options and maybe like pick one of them or just like go to a separate link. Right. So that's typically what a menu widget is. And the key thing, the next thing you want to know about is sort of the different parts of a menu, right? And that's the menu anatomy itself. And the way I like to describe this is more like the different parts of a menu. So when I use these terminologies in describing the menu, I just want you to be sure and know exactly what I'm referring to. Right, so the first one here is the menu button, which is sort of like the trigger for the menu itself. For Code Sandbox, you can see there are buttons on the top right here that you can use. Even for Google Chrome, as you can see here, there are like menus here you can use, to trigger the menu itself. Those are called menu buttons. And then there's also called like the menu list, which is the wrapper or the container for the menu items, right? And that's like pretty obvious. And then when I say a menu item, I'm literally referring to a single menu action or a single menu link there, right? So that's pretty much like what I mean. So I want you to just know this ahead of time while I proceed and talk. Okay, so when it comes to building menus, over the past couple of years, and based on all the different menus I've had to build for Chakra UI, I've come to realize there are two main patterns for designing menus. So one of them is called the Roving tab index pattern. And what that means, typically, roving means like constantly changing or constantly moving. So I'm going to use Code Sandbox example as a guideline here. So when I take my mouse to sort of hover on any of these menu items, what the Roving tab index pattern says is like, as I take my mouse towards them, you literally want to focus on that menu item, right? So what that does is, aside from focusing on that menu item, you want to set tab index 0 for the active menu or the highlighted menu. So as I'm doing this, one of the things you can see is like the active menu would have like the tab index of 0, and it's going to call the focus method. But for other menus that are not active, they get a tab index of -1, which is typically what you call like the roving tab index, which means the current or the active tab index switches to 0 and the other one switches to -1. So the switch of that 0 tab index is typically what this pattern represents. And another common pattern is when you take your mouse away from the menu and no menu is active, you typically suggest that you put the focus on the menu list or the menu items wrapper or container, typically, so that when you do keyboard navigation, you can actually like listen correctly from that place. Right, so the next pattern is called the active descendant pattern, which is pretty similar in spirit with the roving tab index. I think the only difference here, it uses the idea of virtual focus. And what virtual focus means is, it might look like this actually has focus, but it really doesn't have focus. And this pattern literally suggests that the menu list keeps focus throughout the whole time or throughout the lifetime of the interaction. And you have to use some sort of like indexing the menu items so you can sort of pick the highlighted one and sort of set this property called area active descendant. Right, so this property is what this pattern uses a lot to keep track of the active menu item at any point in time. Right, the subtle difference between the two of them, I'd say, is because like one thing to notice, like the roving tab index pattern requires that you have tab index of 0 and tab index of -1 for the menu items, depending on whether the menu item is selected or not. But for the active descendant pattern, most of the time it's recommended that the menu item is not focusable, which means you never really get to see a tab index value for them, and because focus literally remains on the menu container itself. All right, so this is like the two common patterns. I just want to keep that in mind. For this talk, I'm going to be using the active descendant pattern pretty much to show you like how I would build a menu component. All right. So going forward, we'll take a look at the common API designs that exist out there for menu components. And I've done a couple of research to pull together some menu component APIs by going through a couple of design systems out there and just like bringing out all of the code that I find and surfacing that to share my thoughts on them and like how would we design a menu component. Right. So one of the key things I like to do is when I see a menu like this, I always think about it like, how can I describe this UI using React or using JSX? So the key idea for me is how do I use JSX as a design tool to describe this UI for the menu? Right, and then I just go through and do a couple of research to find how are other people out there solving this problem, and then I take some ideas or some inspiration from that. Right, so the first one I would like us to take a look at is Carbon Design System. And Carbon Design System have this component called Overflow Menu, which is pretty similar to what we have here in Code Sandbox, like I showed you. But then the API looks like this. So we have this menu component, and then you have a primary focus selector for a class, and then you have this overflow menu item taking the item text. I think this API is pretty interesting. I think it has some more power in there. I mean, a few things are probably a few thoughts that I have is maybe I might not want to have like this has divider prop and literally let the user be in control. Be in control of rendering a divider in there. Because one of the things I always like to keep in mind when it comes to design systems is the fact that the design of a component can change more frequently than the logic of that component. So what this means is if you're on the design systems team, there's a high chance that when your team switches to a new designer, they're going to go like pretty crazy on the designs. They'll be like, I need to change all of the designs in this design system. It's not looking like super nice. Maybe we can tweak a few things. And the key thing to note is that the logic of the component might not change, but then the presentation of that component might change. So even if you're sure that you're building a design system for a company, because as you bring in more people to your team, there's a high chance that like it might impact the design of that component. So that said, I usually prefer to sort of have like expose as many parts of a component as possible ahead of time, so it's easy to tweak. All right, so that's sort of my thoughts on this. I would maybe expose out the divider component and make it that easy to style as well. I guess it's usually not clear, like how do I style the divider component in event I need to. Probably would have to go into the menu item, but that's okay as well. And then another one I want to take a look at is the Atlassian design system. And this design system for the menu component looks pretty interesting as well. So they have this drop-down menu component and a trigger type, which is, I think that means the button type. I'm not sure. But then they also have this trigger, which is the label for the button. I think this is also like pretty good. I mean, I'm not sure what would happen in event where I need to style or change the style of the menu button at any point in time, because we know that like, I mean, when you're working on a real product, there's a high chance that you might need to style separate components in different ways. And I appreciate the fact that you want to include constraints in your design or in your design system components, but it doesn't always work out the way we want it when it comes to like when the components is used in real world application itself. So maybe what I might change here would be to actually figure out how to expose this drop-down trigger component actually in the JSX itself, so it makes it easy to work with. And that's my thoughts on that. And then they have like an API for a custom trigger, which is like you have to pass the trigger button props. So typically this this triggers some thoughts in my mind when I see props like this, because it literally means that you could render a component there instead of passing props to configure the component internally. So that's my thought here. And then last one I'll take a look at for the sake of time is the Uber's base web design system. All right, so this API looks like pretty interesting. You just pass in a bunch of labels, and then it figures out all the magic that needs to happen in there, which is like pretty interesting to know. I think my thoughts on this is this works. I mean, the only thing I can think about is in scenarios where you need to maybe change the style or change the props of the component for the menu items. Maybe I want to change the color to red because it's a delete action. I'm not sure how this API would work, or if I wanted to disable a menu. I'm not sure how this works here, because maybe I would have to pass like disabled equals true. At this point, it starts to feel like the component, you're sort of configuring the component instead of composing the component. And every time when I build components, I always advocate for composing and composition itself, as opposed to like configuring or sort of passing some sort of config object, whether it's props or some array. I tend to prefer those kind of APIs. That's just my personal opinion anyway. So that's it. The final one, which I find really interesting and probably be like the go-to API for me, is Rich UI. And Rich UI's API is also like, it's fairly explicit. You can see every part of the component. There's a menu component, there's a menu button component. And this is what I'm referring to when I say I want to see all the different parts of the component. Even if they have their own styles or they have the styles baked in, it always feels good to be able to see the component. And even I need to take a specific, maybe there's a ticket in Jira that I need to maybe change the styles, a one-off kind of thing. I don't want to have to go to CSS to just like tweak that one-off thing. I can just maybe pass a style attribute or a style prop and just like change that at that point in time. But these are like different types of API, and you see the menu list, you see the menu item. So when it feels to me that the anatomy of a component and the code of that component matches one-to-one, then I feel like pretty comfortable with that kind of API, because you can see here the anatomy of this component, and you can also see from the JSX code here that it feels pretty much like everything maps one-to-one to themselves, and sort of feels like I have more control over this component and how to style them. Right, so styling is not the only use case where you want to favor composition. Typically, you also want to do things like, for example, maybe adding an icon or adding a command, or configuring the menu in such a way that doesn't exist before in your design system. So this is why I typically love to favor composition over configuration. All right, so how I would design this menu, when I took some time to think about it, if I wanted to build this menu from scratch, I think I'd most likely favor the last one I showed you, which is the API design from Rich UI. And this is pretty much how I've described this component design here. So I would go, the menu component sits at the root of everything. Maybe I can put all of the logic for that menu in there and maybe pass that down through React context to all of the components. And then I can maybe expose this menu button component that reads from that React context and provides all of the actions like on click, open. When I click on the button, I want to show the menu list. So that's kind of like what I'm thinking about here. And this is the menu list itself. It's just a container around all the menu items. And I see each menu item. And maybe I could include a prop code command, which is like adding a command to that menu item. And here's what I mean when I say I'd love to see the divider being explicit. So I can also sort of inject a divider in there and say, hey, this is an horizontal divider. Even if it comes with its own pre-made styles, I personally feel like it just makes more sense to see the menu divider components there, so it's kind of easy to work with, and also just add multiple dividers at different points or style the divider in different ways. Right, and that's it. And maybe other things I could consider is things like prefix. If I wanted to include an icon to the start position of the menu or the end position of the menu, of the menu item, then I can maybe include this prop here. So this is how I tend to think about the component. I start with the design, and then I try to sort of write the JSX code of how I think, sort of like a pseudocode or a mental pseudocode of how I think this component should work. And then I go into the code itself. All right, so I hope I'm not out of time, but I just want to like quickly walk through a couple of things with you. So now is the time where we start to think about the menu design specification. So typically when you work on components, I always recommend to go through the W3C recommendations or the specifications for this design pattern for a menu. So right here, we have like the pattern we're going to be looking at. So we're going to be designing an action menu button. Remember, I mentioned there are two types of menus. There's the navigation menu, which is basically a menu of links, and then there's the action menu, which is a menu of actions, typically. So this is the pattern here where we're going to be designing an action menu. Using the area active descendant pattern. All right. So what I do when I have to design a component, I go through the menu design specification. And I see, I just sort of read through, okay, this is an example. When I take my mouse to that, I see that the focus is wrapped around the menu list. Please don't forget these terminologies. I don't want to lose anyone here. So you can see the focus goes around the menu list, and as I take my mouse through, focus never leaves the menu. The only thing that happens is the area active descendant attribute gets changed to the currently focused item, and this works pretty well for keyboard as well. I'm not sure why the page is scrolling here, but I assume I wouldn't say it's intentional anyway, but that's typically like what it is there. And here you can see the specification for that. So for the keyboard support, which is making a component accessible from a keyboard navigation perspective, this is like the spec for that. So it says that when you focus on the menu button and you press the down arrow, or you press space, or you press enter, it opens the menu and moves focus to the first item. Right, and then when you arrow up, it opens the menu and most focus on the last item. Then there are a bunch of other specifications here as well. For the menu, when you press escape, when you press up, when you press down, when you press home, when you press end, and maybe when you want to search with a character. So if you type E on your keyboard, it should match an item that starts with E. Or if you type A, it should match an item that starts with A. So that's kind of like all of the different properties. And when I read this specification, one of the things that come to my mind is how can I describe this component logic and this specification in a way that is sort of somewhat framework agnostic, or in a way that's sort of easy to follow and understand. Right. So that leads me to the idea or the concept of like state machines themselves. So just give me one moment, trying to track time. So that leads me to the idea of state machines. So the concept of state machines typically is to be able to sort of every component. I think let me try to rephrase that a bit. Every component has a possible number of finite states, right? And for the menu component, it's pretty interesting. I'll show you what like the finite states of that menu could look like. Right, so the menu at some point gets idle, and then maybe I use my tab key to get to that menu button, and I press enter or I press space, and then the menu opens up, and then I send focus to the menu list. And at that point in time, when I use the down key or the up key or escape, all of those interactions are expected to work correctly according to the specification. Now, because of this, because we can already see a number of finite states, what always comes to mind is like, how can I just describe this in a way that just works, regardless of the framework that I use? Because most of the time in design systems, we like to make our UI components work in multiple frameworks. So for Chakra UI, we want to make Chakra UI core ideas or logic work in both Vue and in React. So for me, as the core maintainer, I'm thinking, how do I make sure the Vue maintainer does not do double work in having to describe or write the code for this component, right? So I say, okay, so I stumbled on the idea of state machines, and I thought, okay, let me just try to see if I can figure this out. At least, before this talk, let me see what I can do to sort of get some ideas and sort of show you guys what that looks like. Right. So the key concept of state machine is the fact that like you can describe the number of states. For example, this menu component can be in idle state, it can be in focus state, and it can also be in the open state, right? And the other key ideas here is you can specify this on property on each state that sort of defines the events that can happen at that state and what should happen when you actually trigger that event or when that event is fired. Right, so here it means when I toggle, I want it to go to the open state. Toggle means maybe when I click on it and I click on it again. So when I toggle, I want to go to the open state. And if you check the open state, and maybe when I send an event called close, I want it to go to the focus state, which means sort of send focus to the menu. So this is sort of like the basic idea of a state machine. And we can include other concepts such as the initial state, which means of these three states, which of them should be the first or the initial state of the component. And you could also include extended state information or context data, which is more like any state information, which is the count or pretty much anything you'd like to keep track of and you'd like to change in the course of your machine. Okay, so that's pretty much like all of the talk. I want to see how much time I have here. I have 21 minutes. Let's see like if I can walk you guys through like all of different, quickly modeling a state machine for a menu component. All right, just give me 1 second. Okay, so here we go. So to get started with this, one of the things I've done ahead of time is to prepare a couple of code for us, but then I'm going to focus a lot on the machine itself, right? And then we'll go through the specification here, and then we'll sort of try to describe the logic of that component, right? So here for the menu machine, I mentioned earlier that we have the idle state, we have the focus state, and then we have the open state. So we'll see like how we can quickly model the states of this component using this state machine idea or this state machine logic. One of the key usefulness of this is, obviously I've gone ahead of time to write this before, so I just want to show you one of the key benefits of this, using a state machine. One of them is that you can easily visualize the interactions or the states of the component. So you can see here that like I can sort of like test out the logic of how this menu works. So I can like, okay, when it's idle and I click on the button, oh, okay, the button opens up. Interesting. So what happens when I do arrow up or arrow down? Okay, maybe the button is still open. That's interesting. But then it's doing some extra stuff, such as like focusing on the next item or focusing on the previous item. So this is sort of like the key idea and one of the huge benefits for me, why I think modeling components in state machines makes sense, because it's easy to visualize that logic and find and spot bugs, not in code, but in a much more visual way where you can show the person, hey, I think the logic here doesn't work or it's wrong. Okay, so for the sake of time, I'm going to sort of bridge through most of this. When we're in the idle state, there are a couple of things we can do to this button, which means maybe we can click on that button. So I'm going to say on the idle state, I'm going to say on click of that button. So this on means like when I click on that button, I want it to open. So which means I want to go to the open state of the menu. Which the open state means the list is active, the list is open, and it has focus, right? So the next thing I want to do is then maybe I can change this on click. So if you use a bit more descriptive, I'll say like on button click, which means when I click on the menu button, I want it to go to the open state, right? So the next thing I can also do from this state, idle state, is to use my keyboard. So what happens when I'm just simply tabbing through the component? What happens in this scenario? I think what happens is it goes to sort of like a focused state, right? So I'm just gonna maybe call this focus instead of close. I'm gonna call this like the focus state, and I'll say when you focus on the button, which means like on button focus, I want it to go to the focus state. Yeah, so this sort of like helps you visualize to see, okay, interesting. So I click on the button, it goes to open. When I focus, it goes to focus. Then let's go through like when it's open, because that's literally where it gets like pretty interesting. All right, so when it opens, there's a couple of things I can do. One of the things I can do is to click the menu button again, or simply click outside of the menu list or the menu button. Just click anywhere in the document. So I'll say, okay, when it's open, I'll probably use the on keyword again, and then model a couple of events. The first one is when I click on the button again, I want it to go back to the focus state, which means it takes focus back again to the button there. And then the next thing I would say is on blower, which is also, click outside if you prefer that. I also want to take focus back to the menu button as well. So that's like two pretty easy scenarios, and this feels more like reading English language typically, and just like reading the text. It feels more easier to follow compared to when you had to write, or if you had to write a couple of use effects throughout the code to just make sure like all the states are syncing together and all the actions are firing. I cannot just like the way and the expressiveness of state machines. Right, and then the next thing we can do here, now that it's open, is that the focus sort of moves to the menu item. That's like one thing we can see. So anytime the menu is open, the specification says takes focus to what it says is just when the menu is open, focus goes to the menu list. So I tend to like treat these as side effects. Opening a menu is obviously a declarative action, but focusing on the menu list is some sort of like side effect of opening the menu. So what I'll do then is Steam machines have the concept of entry, which means like, I mean, what do you want to do when the menu is open? So I'd say maybe I want to focus the menu. Exactly. So this is literally what happens here. So you can see I haven't written any code just yet, but I'm going to delve into that as well pretty quickly. Right. So I modeled a couple of more states here. So next thing I can do is when I hit the escape key. So I'll say when I press the escape key, I want it to also go back to the focus state. I want it to take the close the menu and sort of take us back to the focus state, which is this state where the button is focused and the menu is not open. So that's sort of like what happens there. And then I'll probably model the keyboard interactions, which says like arrow up. So when I sort of like do arrow up, I mean press the arrow up key. What happens when I press the arrow down key? Come on. What happens when I press the arrow down key? What happens when I press the home key? And what happens when I press the end key? Right. So this is like these are all the different parts of the interaction. Maybe what happens when I hit the enter key as well is also like pretty interesting, because if you follow through like all of this, you can see all of these specifications. But for the sake of time, I'll probably not like go through all of them here one by one. So that's pretty much like what is happening here. So I'll pretty brush through this. So going to this state is sort of like the shorthand way of describing what happens when I do this action. Another way is to do like target, which is if you wanted to, so this syntax is sort of like the long way of saying this same thing as well. The only thing is this allows me perform some actions. So this is like, what do you want to do when you press the arrow key? So aside from changing the state to any of these possible 3 states, I can also like take some actions. In this scenario, I want to keep the menu open. I don't want to close the menu. So I'm not going to define a target. I'm just going to define the actions that should happen here. So I'll say focus, maybe I'll arrow up means maybe I want to focus the previous item, which means I'm pressing the up key. I want to go to the previous item. And arrow down means I want to maybe focus the next item. So for a vertical menu, I just want to go through the items there. And then the home key, what I want to do here is I want to focus the first item, because that's typically what the home key does for common widget interactions. And for the end key, maybe I just focus the last item. Yeah, because that's what the spec says, obviously. So the next thing we can model here is what happens when I hit the enter key. Right. So the enter key here does like 2 things. So while I'm navigating through with my keyboard, then when I navigate, maybe I go to edit, or I press down and I go to duplicate and I press the enter key. What we want to happen then is it should go back to, so to say, the focus state, which is this state here. But at the same time, we want to tell it to, maybe we can tell it to select the current item. So which means like, just let me know what the current item was before I press enter there. All right, so this would maybe help me report that logic. And now we're done with like the keyboard interactions. Let me keep track of time again. 12 minutes, interesting. So what happens, we're done with sort of like the keyboard interactions here. So the next thought would be, what happens if I use my mouse? So I sort of take my mouse over here and I try to interact with this component. So what I'll do then is I'll try to model these parts as well. So the first thing I'll say is when you take your pointer over this item, I tend to use, like, instead of saying mouse over, I tend to use the word pointer over, because you can have like multiple inputs, not just the mouse, typically. All right, so what happens when you hover on this item, which is pointer over? What I want to do, the action now, I still want to keep the menu open, so I'm not going to define a target or the next state, because it's still the open state. What I want to do instead is to focus on the item itself, which means if I take my mouse to duplicate, keep duplicate focus. So in this case, because it's the active descendant pattern, sort of just highlights that menu item and sets the area active descendant attribute to be equal to that item's ID. Right. So, and then the next one I'll do is what happens when I take my mouse away from that. So I'll say pointer leave. what do I want to do here? Pointer leave would be like, maybe I just reset the ID or the active descendant ID. And that's happening because like based on this pattern, I need to keep track of the active descendant of the menu. Right, and that's this one right here. So it says like for the menu, for any item that has the role of menu, what you want to do is to pass this area active descendant property that should be equal to the ID ref. An ID ref refers to the ID of the highlighted menu item. All right, so that's typically how to interpret that there. So that means I need to sort of figure out like how to keep track of this in my machine. So I create a context for that, and maybe I'll just like pass a couple of things. For example, one of the things I could pass is the menu ID, and I could also provide an ID for the button. And then I would say the active descendant ID. I'll probably start that as an empty string for now. And the next piece would be I'll probably come back to this later on. TypeScript is not happy with me. Then on select, which is sort of like the method that gets called when you select an item. So this is typically happening. This is what happens when you use the keyboard and you press enter, or you take your mouse to one of the items and you click on it. I want to be able to invoke this method. So I just store that in the context. Remember, the context is just some extra information lying around in my machine. All right, so what I'll do then is I take all of these items here and I just try to interpret them. But let's not forget we still have the focus state, right? So a couple of things happen in the focus state. When the menu is focused, or when the menu button is focused, the spec says we can do a couple of things, right? So here you can see the menu button specification for keyboard, which means when the button has focus, arrow down should open the menu and move focus to the first item. Arrow up should open the menu and move focus to the last item. So what I'll do then is to come here and say, okay, in this focus state for the menu, a couple of things I can do is, first of all, when I do something like arrow down, what I want to do then is to open the menu, which means I take the menu to the open state, but at the same time I want to focus the first item. All right, so this is more like just describing everything that's going to happen ahead of time. And then when I arrow down, or when I use arrow up, you can do like, you still want to open the menu, but at the same time, the action you want to take is focus the last item. Right, and that's it. And the last thing is in this focus state, obviously I can just like click anywhere in the document, which is considered like a blow for that button. So I do like a button blow event. When I blow that button, just take it back to the ID, which means like nothing is happening for this menu item anymore. Right, and there are a couple of side effects I need to take care of here. One of the side effects of closing the menu or taking the menu back to the focus state is that we need to sort of clear this active descendant ID. So I'll walk you through. I'll show you how I'm able to do this. Maybe not like live, but I can just like show you snippets of like how I'm able to achieve all of these different pieces. Right. So one of the things I want to do is when I sort of like click on this menu item, it opens, and I click outside, it closes and takes focus back to the button. But because at that point when it's closed, no menu item is selected, I typically want to reset this active descendant ID because, hey, no menu item is active anymore because it's closed, right? So one of the side effects of being in this state, which is typically like the focus or the closed state, I just want to reset that ID, and I want to make sure that the button remains focused. Right, so I consider doing focus events or focus as side effects of being in a specific state. So being in this focus or closed state, I literally could not find a better name, so just use close. And here I'm just using focus. So pardon my confused mind. I'm just gonna use focus here for the sake of this talk. All right, so now that I've described, I think this is like a pretty solid way to describe like the logic itself. One other thing I can do here is when I click on the button, maybe I don't just want to go to the open state. I want to do something pretty similar to this, which is I want to go to the open state and focus the first item. Because typically a common pattern is like I'm not sure if that's common in general. Like when you open the menu, at least let's put some focus on the first one, so the user can maybe start using your keyboard and like interacting with the menu item. And that's also exactly what the spec says. Here, when it says like space or enter, typically means like you should open the menu and put focus on the first item. So this is how I'm going to describe that here. So now that I've described all of these states and the actions and everything that's going to happen to the button, let's go write like all of the functions to do like most of these things. Obviously, I'm not going to write everything here for the sake of time, but then state machines have like a way to sort of like implement these actions. So what I've done here is I've just tried to use like normal English language or text to describe what should happen. But then here comes the JavaScript of like, when you say focus previous item, what do you mean? And when you say focus next item, what do you mean exactly? So that's where like this comes into play. All right, so because I've done most of these things ahead of time, I'm just going to sort of like copy over the code and sort of put it here and walk you guys through everything that's happening, so I don't take too much time. All right, so here, it's like a paste failure, I guess. 1 second. Grab it here. Actions. All right. Time to import assign. And just import a couple of these helpers here. So what I'm going to do is I'm going to have to write like a helper method to help me sort of like do a couple of like document the query selector for the menu items. All right, so I'm going to walk you guys through like what I've done here in this code. So when I say it should reset ID, what it means, as I mentioned earlier, means like when I'm resetting an ID, it means there's no active menu, or there's no menu that's sort of hovered on or interacted with, so it's sort of been closed. That means I set the active descendant to null. When I say you should focus the menu, I sort of do a document a query selector or get element by ID on that menu ID that's stored on the context. Remember I told you can sort of store stuff in context, and then I call the focus method of that menu. I move most of all this work to the next tick, just to get it to get the focus right and make sure it actually sticks. All right, and then the next one is focus first item. So I've then done a couple of like menu.query selector for the menu items, and I grab the first item in that array from the node list, and then I grab the ID of that item. And then it goes on and on, which is like get the next item, get the previous item. All I do then is typically just like take the index of this active item, go get me the index. What does that index look like? So what is the next one from that, which is where you see items that get next of the index, and I grab the ID of that item. So for the sake of time, I won't get into like all of the nitty-gritty details of how to get to this, but then this is typically like how you would describe this logic. And if you take all of these definitions that I've shown you here, and you put that on here to like XState visualizer. So XState is a powerful library that powers most of the state machine concepts in the JavaScript ecosystem. As you can see here, I mean, nothing looks or nothing feels strange. Typically, we have the idle. Again, from my confused mind, I use close here. So just skip that one. So what I've done here is exactly the same code that we had there earlier. But then this is the visualization of that. So if I reset the machine and I click on the button here, you see that it goes to the open state, and then you can take specific actions. So it shows you that, hey, when you send an event called arrow down, focus the next item. When you send arrow up, focus the previous item. When it's open, I can click on the menu button again. That's going to take me to the closed state. And the closed state, when I arrow down, it goes back up. It goes back to the open state again. So it just makes it easy to see all of the logic for that menu component. All right, so enough of all of this. To wrap up, I'll show you like what the final output looks like here. So I'll take you to the app here in Code Sandbox, and you can see like pretty much like all of the setup that I've done, like sort of to get the menu component working. And what I've done typically is I took the machine we just made now, and I sort of set the initial values for the context, which is, I just want to set the ID myself here in the component, and there's this use machine hook. I try to sort of write some sort of a way to translate the machine state, and I mean, think of state and send as like the dispatch of, if you're used to Redux patterns or the reducer pattern, send is most like equal to dispatch. I just like to call it send because it means you're sending events. You can also call it dispatch events. That's up to you. But here, what I've done is I've tried to sort of break down all of the menu items, and I sort of convert everything, I map everything here using this like map machine to props. And this is really interesting. I'll probably just like quickly show you what's going on in there. So what I'm doing here is sort of taking the machine output and all of the things we've done so far, and then we are able to sort of map that to DOM attributes. All right, so this means like for the button, there are like attributes here in the specifications that you need to apply to the button itself. So what I've done is to take like all that work and wrap it up in a function. So to get the menu button attributes, you can sort of put this here, area expanded, area controls. When you click on the button, you're sending this event. Remember, these events represent like all of this stuff we put in the on property of the state. So particularly just like taking that and sending that, just calling send with all of that, and the machine would ensure that like, I mean, it works properly the way it should and the way we've modeled it. Right, so I'm just taking I'm saying, hey, when I key down, I'm creating a keyboard map, a key map for all the events, and preventing default for the one that matches. I'm calling that function. So this is typically like everything that I've done here. And then what is happening here is you can see here that when I click on the button, it opens the button, puts menu on the first, focus on the first item. Then I use my keyboard to sort of navigate like up and down. You can see that the active Descendant ID is sort of changing to match like the currently active menu item. And then if I maybe like hit the D key, it's going to focus on the first item that matches the D. Now hit D again, it focuses on the next one. I can hit E or I can hit escape. Escape would close the menu. Like I mentioned, because this is closed now, or focus close, like anything you want to call that. Then you can see that the active Descendant is null and the state is actually closed. And when I click outside, the state is idle. So when I open this again with my keyboard, with my mouse, I can also use my mouse to sort of like the pointer to hover on any of these items and also leave. So you can see sort of like this detailed interaction. You can click the menu button back again, going back to the closed state, and blur again, goes back to the idle state. So this is like the key idea or the concept behind creating a state machine for the menu component. I'm building a component in a way that like is very easy to visualize the logic, share the logic across multiple frameworks, and ensure that there are literally no bugs in the component code, because you can literally spot them by looking at the visualization of that logic. I hope you've learned a lot from this talk. And I know the concept of state machines can be quite overwhelming for those that are not aware of it, but I think there's a lot of benefit and advantage that comes from using and getting familiar with the state machine, because it saves you a whole ton of stress. I hope you enjoyed my talk. If you have questions, I'm happy to take them. Thank you so much.
Thank you so much, Sage, for sharing this amazing talk and your fantastic approach. Everyone, if you have any questions for Sage, please do not be shy and share them with us using the Slido. So we're going to have a short Q&A after both of the talks. Post any questions that you have in the Slido. Let us know if you have any problems posting the questions, if you have any questions around posting the questions too. Sage, thank you so much, and we will be circling back with you for the Q&A. Next up, we have our second talk, one from Boris, a front-end engineer at AWS, and he's going to talk about the AWS Design System 4 years later. Boris, over to you.
Hi. Hello, everyone. I'm very glad to see you here. My name is Boris. I'm working as a front engineer at Amazon for a little bit more than 4 years. In particular, I've been working on this design system, and today I want to tell you 4 years of its history. But before all, let me introduce you what AWS is about. You probably already heard about this project, or maybe you use it in your own products. Currently, we offer many different services in various categories. We offer compute services, serverless, analytics, IoT, and many others. And all these services also have some special web UI where you could interact with this service, do some configuration, make some operations. We usually call these services consoles, and they need to have some sort of UI and components. But we did not always have that many services available. We started with just a few, and year over year, we released more and more features. And here you can see some historical data, how many features or like service additions we announce it every year. And as you can see, every year we announced more services than the year before. And working on this scale, we need to focus on the efficiency, and we need to make sure that our designers and engineers do not build the same thing again and again. And instead, we should allow them to focus on what makes the service unique, what is their unique features, instead of just reinventing the same button 100 of times. We somehow need to avoid this burden. And this is the state where we got started. Here you can see some screenshots how AWS consoles look at that moment of time. Even though they all follow the same style guide, they do not look like they belong to a single big service. Some elements are different, some elements are special on each case. And that was not only about us, designers or developers, being upset about these small inconsistencies. Usually, as an AWS customer, you have a special workflow which requires you to visit multiple services. You configure something in one service, then go to another, check how it's working. And when your elements on different services behave differently, it could be frustrating. So we need to work something. And here comes the idea of unification. What if we create some shared UI library where we create all the design components and allow customers to use these components instead? However, it's always difficult to begin. This approach already worked for other companies, but it's very hard to take this approach and just apply to the existing code. So how do we start? We began with trying to understand who we will be building this system for, who is our customers. We try to find the teams who are building the current consoles and try to understand their needs, what components they need, what kind of use cases they need to support, and how they build them together. We also needed to learn about their technology stacks, what frameworks they use, what technologies, and how we could integrate components into their existing setup without the need to rewrite everything just to add a button. And we also needed to think about communication channels. When we gave them components, we also wanted to hear back how they like our components, if there's anything we could improve. So we needed to make sure that they are able to report us bugs and they could ask us for extra features. And after some work, we have released the first version. Hooray! And this is how it looked like. In the beginning, we had only 15 basic components like buttons, form fields, and other kind of controls. At the same time, we supported multiple JavaScript frameworks at the same time because the existing products already were based on multiple frameworks, so we needed to support them respectively. So they do not need to drop the entire code base and migrate to the new framework just for the sake of using a new component. Instead, we should give our components in a compatible way that they could install them right in their consoles. And this is how we got our first customers. They started using our components, they integrated them into their interfaces, but we quickly realized that they need more components. We have built 15 components, but they could not offer all different use cases. So we needed more. We also figured that when we provide such generic components like buttons or inputs, it's very hard to put them inside some context. It's hard to understand how to use a button properly, especially because button could have different variants, and it's not clear which variant you should use for a particular case. So we needed some sort of high-level guidelines. more high-level documentation. So we got back to work, and shortly after, we released the second version, where we try to answer all these questions. First, we try to unify the top-level experience, which we addressed by introducing a layout component. This component takes care of the general page layout. It takes the page and provides some special slots for each content. Here we can see navigation slot to the left, primary content in the middle, and some additional sidebar where you could, for example, render a help article. And by adopting this component on multiple pages, we give users some sense of consistency. They always know where they can find navigation, it's here, or where they could find breadcrumbs, they're here. And by giving this, we always help them to navigate through the interface. Then we also worked on the table interfaces. There are many tables in different AWS interfaces. You could see them pretty much in every console. So this is why it was important to provide a unified version of it. And we try to address this demand by introducing the table component. However, this component is not only for displaying the static table data. It is also an interactive one. Here we could filter the elements or paginate or do sorting. And as a developer, you do not need to implement these features yourself. The component brings them built in. You only need to install the component, provide some data, localization strings, and component will do all the work for you, how to handle events, how to paginate and navigate through the items. After that, we also addressed the documentation request. In the previous version, we provided some basic API documentation, some component demos. In this version, we took it a little bit further. We also provided some additional usage guidelines. We describe it, what users should do with the component, in what context developers should use it, and what context they should not. We provided some additional documentation, how to write text content, how to make sure that all captions look consistently, and other improvements in this way. Then we also created some demo pages. One of them you can see here on the screen. This is not any real console. However, this is a representation what you could achieve by using our components, joining them together. And we created several pages for the most popular usage patterns, how our pages should be looking like. Developers could inspect the source code of these pages, try to understand what components are used and in which way, how they are connected together. They can also inspect the source code, understand how it's working, and even copy and paste some fragments to their projects to get stuff ready to use quickly. This way we have got more customers, but more customers also means more feedback. We have learned that there are even more use cases which we needed to support. However, at the same time, we already had many people depending on us. They use our components in production. So while we supported more cases, we also should not forget about the current customers. We should give them some stable APIs and like no regressions. So it was a very tricky balance how to keep while moving forwards with the new features, but also maintaining backward compatibility. Many customers at this point asked us a question. We already offered two major versions, 2.0 and 1.0. And we have already got a backlog of potential breaking changes. And customers asked us, what if the new version will be released? How hard would it be to migrate to it? So we took all this feedback and we released a new one, 3.0, where we tried to address the new questions we've got. First of all, we introduced the concept of CSS scoping. Usually, when you work with CSS, it applies globally to the entire page. And if you create class names, sometimes you could have unfortunate overlaps where you created different class names that were meant for different elements, but they apply to the same element because an unfortunate name matching. In version 3.0, we try to address it by switching from human readable names to some automatically generated hashes. they are by definition unique and don't overlap with everything on the page. And this enabled customers to do incremental migration to the latest version. Now they do not need to stop their feature work and just spend time on migrating from the previous version to 3.0. Instead, they could keep the previous components on the page and just add new components for the new features, and then later migrate page by page or screen by screen in a gradual manner. They do not need to do it like all in one go. Could be done gradually. CSS Scoping also supported additional patterns that we could not do before. For example, now we could use micro frontends. This is a pattern where multiple teams could work on a single page, and they will not conflict with each other because everything is isolated. They could have different versions of our library, different releases, and it all will be properly separated. Another benefit of CSS scoping that generated names do not allow overrides anymore. If previously some curious developers could go into the source code, understand what class names we use, and apply some additions, now the names are generated, so they could not recreate them on their side. And this way we could ensure that components look exactly the way that they were expected to be by design. Another improvement we did about responsiveness, which I'm trying to show on this picture. This is how it worked in 2.0. We used classic CSS media queries. They work, for example, here. We have a typical 3-column layout, and on the right screens it is 3 columns, and when we go to an arrow viewport, it could wrap into a single column. However, when we place the same component on the same screen on a smaller sidebar, they will not wrap as we could expect, because media queries always attach it to the width of the entire page. They do not know in which container the content is getting rendered. So it always will inherit the width of the page, so it assumes that there is enough space, whereas in fact it's not. In the version 3.0, we replaced this logic with what we call container queries. We provided some additional JavaScript logic, which will look up to the nearest parent container, understand the size of it, and applies the layout changes accordingly. So the layout will now detect that it is inside the sidebar, and you need to wrap to fit the content. To ensure that all these interactions are smooth and performant, we used Resize Observer API, which is built into modern browsers and allow for performant implementation of this behavior. Then we also worked on non-visual improvements for the components. In the previous versions, we introduced a table component, and it worked great for many cases. However, it was bound to the actual representation of the table. It could only render the table. In the new version, we decided to extract all the data manipulation logic into a separate package that has no UI, only the pure data logic. And we call this package collection hooks. And now this could be plugged into any kind of UI. It is not bound to the table anymore. It could be any other kind of collection, list, cards, or any other UI, and it all will have the same consistent filtering and pagination logic that users would expect from their experience with previous components. And then we also thought about new customers, how new people could onboard and start using our components. For them, we created a sample project which already configured the standard setup, React, TypeScript, and Webpack. So if you're building a new project and you would like to use our components, you don't need to spend this time yourself. You could just clone our sample project and you will start building the new features very quickly. We also thought about previous customers who already have existing projects. To help them out to switch to the new version, we created some automated scripts which allow them to just run the script over the existing code base, and the script will automatically replace all breaking changes as much as it could detect statically. For example, it could detect a renamed property and rename it automatically. So as a developer, you don't need to go and do it by hand. You'll just run the script and you will see the result. And again, as long as we start getting more customers, we also realized that our team could not help handling all the requests that are coming to us. So we try to somehow improve the project. First, we opened what we call an ambassador program. Our community, there were some active members of our community who already had very long experience with our components, with our design. They had some deep understanding of our patterns and our decisions. So we nominated them to become ambassadors, people who could help other people without waiting for our team to respond. This way we could help community members to support each other. They do not need for us to wait for a response or a review or any kind of design feedback. Instead, they could reach out to an ambassador and will get the same feedback, but much earlier. I also encouraged community to share their innovations. If a team builds something that they believe could be reused across multiple interfaces, something that is worth sharing on the design system level, we encourage them to contribute it to our community page. On the documentation website, we created a special section where they could provide their pattern, and other people, when they will browse our documentation website, they will not only see our official components, but they will also see what else community has to offer, what else is happening, and what could be useful for them. We also thought about making our code base a little friendlier. Previously, we were using our custom internal framework, which required some time to learn and onboard before you will be able to do productive changes. In the new version, we replaced it with familiar React technology stack. So now any contributor could go inspect our code base and contribute as small bug fixes or little improvements very easily, because they will be already familiar with the technology stack that we use. And this is where we stand today. We have built a design system that is used by many AWS consoles, and we also have grown from 15 components to 50, and these components have additional guideline and documentation articles which explain how to use these components. And when it's not enough, we also provide some real-world examples, some demos where you can see how this component looks in action in the context of a bigger page. But we do not stop here. We continue building our components and releasing new features. However, for today, if I were to give you some last advices, I would give you the following. First of all, it's better to connect with your customers, understand how they use your components, what difficulties they have, and how you could help them to improve. So it's very important to keep the feedback channels open, listen to customers, receive their bug reports, feedback, and respond. Then it's also important to enable customers to iterate quicker. For example, when it comes about API of a component, you could think about reasonable defaults, where all the common use cases are already enabled by default, so you can just plug component in and it will work. And you will keep properties only for advanced cases, which are not often needed. And this way, customers could focus on building the features that are unique for their services, instead of spending a lot of time trying to understand how to configure a component. And as long as you're getting more to the production state, it is important to think about long-term promises. How you will keep backward compatibility, how you will think about breaking changes, and the migration story for the customers. How will you keep their trust and the way they believe that you will provide the features for them. So this is what I wanted to share for today. Later you can reach me out on Twitter, or you can also ask questions here in the tool. Thank you. Have a great evening.
Thank you so much, Boris. Perfect. The talk was really, really interesting. Thank you so much for sharing all of those amazing insights and history. Community, if you have any questions for Boris, now is your chance to ask them by going to Slido. So feel free to ask any questions that you might have to Boris or to Sage. And with that, I'm going to hand it over to Vic for the Q&A session. So Vic, over to you.
Hi, everyone. Yeah, fantastic talks, you both. I'm going to be facilitating Q&A tonight. And a little bit about myself. I'm a product designer at GitHub. I'm also based in Berlin, like many of us. I used to work more in design systems, but as a product designer, I now work mostly with design systems. And I'm also not a technical designer, despite working on developer tooling. But anyway, I'll try to wing it and bring my design perspective into it. So first of all, Sage, a few comments before jumping into the Q&A session. I love the idea of one-to-one mapping. As I mentioned, I'm not a technical designer, but I could actually read the code and understand how UX behaves. And it kind of told me an actual UX story and described the behavior of the components. I see kind of a magic in there because this is what we're trying to do in design, working with different kind of domains and disciplines across the organization, right? We work with engineering, we work with product, and we try to reduce the cognitive load of understanding how things work and making it easy to maintain and contribute. And I think this was kind of your initial goal with that as well. One quick question, like, do you have any other examples of reducing the cognitive load when you're working the different domains? I think one that comes to my mind is shared naming conventions that the teams could use together.
Yeah.
Is there anything else you could?
Yeah, that's an interesting question. And I mean, I understand that sometimes it feels like the cognitive load of like building a component is a lot. One of the best ways I've found is to like reduce, like chunk down the component into different parts, right? So that's why I started with like looking at the UI, writing what the code should look like. That's like the first place, because there you get alignment as to what do we call this prop? How should we like reorder the component? What name should we call them? And that's sort of like the first part of that. And then it goes to like, okay, how do we describe the logic of the component? I mean, in a way that's sort of easy to understand. And then it goes to like, how do we actually implement the code to do certain things? So like the more you sort of like put a lot of like this code or different parts in compartments, like just like cage them, like make sort of group the tasks into smaller chunks, it kind of makes it like easier for people to like follow through the code. Okay, this is the part, this is the design that the product engineer or designer made. This is what the code should look like at the end. And then I work backwards from there too. This is the logic, or this is where the JavaScript stuff lives. I'm like, okay, this is the spec I need to work with. It gets really interesting because like you could definitely model a lot of these things like with React in a very simple way, like just use state, click here, and then it's done. But then when you want to build a truly inclusive component, I would say like it's quite a lot of work to do. And that's why it's important to follow through the specification. And I always believe in breaking things down into smaller chunks and sort of tackling them like one after the other. I'm not sure if that answers the question, but that's why I tend to think about it in a way that like chunk it down and tackle it one at a time. Yeah.
Yeah, it's really inspiring what you do with Chakra UI. I was just looking at it. I might dig in as well. I also liked how you say the logic of what you're building might not change, but the presentation might change. And I think that kind of resonated with me a lot because so much in our industry just changes and shifts all the time. So it's pretty wild to keep up, even with like ever-changing design changes. And then on top of it, we have technology changes, accessibility standard changes, programming language evolution, etc. Like, how do you manage to keep up with that?
Yeah, exactly. It's actually like super challenging, honestly. And this is what really brought me to the concept of state machines. Because yeah, I mean, I just showed you the spec, the W3 spec for the menu component. And honestly, that spec has been live for a long time. I think for close to 4 to 8 years, the talk has actually been there. That spec is there. So I'm like, regardless of the framework that comes out, whether it's like today we're writing React, next 2 years we can be writing some Vue.js, and then it's like, I mean, we don't want to have to do all of the work it takes, I mean, to actually like now start to write this new Vue.js language. We just want to be able to take whatever we've done before, move it over, and do a couple of style changes, and sort of like that's the answer. I've been in a search for a more permanent way to do stuff, so that regardless of the framework changes or the new cool thing on Twitter, I mean, I don't get to write so much code. Like everything just stays the same. I just copy paste and I move on. And what's really interesting to me is like, I want to be able to just do a work once and use it in multiple places, right? Because I'm tending to get like quite lazy these days. So I just don't want to like do the same thing again. I'm going to put all my focus one time to do like everything and knock off this component. If I need to use it in React Native, I'll copy over the machine to the React Native and like do everything in React Native. Or if I want to write Ember.js or Vue.js, copy the machine over there and like knock it off and just do some styling stuff, and that's it. All right, so that's kind of like how I see it. But I can definitely relate to the fact that it's quite a lot to keep track of like all these different moving parts. I think most of the time you gain control over time as you work on it. So like instead of attempting to keep track of like accessibility and like color and like JSX and states, and it's like you really burn out really fast. So what I always do is just to paste things out for myself. Before now, I probably did not know so much about state machines, but I tried to do some work, do some experiments, and then it felt like super easy to follow. But it takes time, typically. Yeah.
Yeah, I can totally relate. All of us just want to wipe instead of update their libraries.
Yeah.
Boris, I really liked the idea of ambassador program in your talk. It reminded me how when I worked at Microsoft, I used to also work with together with the team that worked on Fluent, that's Microsoft design language. And this is also how we kind of identified the leads in different groups because we had to service like a number of Microsoft products. And one of our challenges that we tackled was ensuring that our customers followed the guidelines that we established. So I think the question that I have to you, how do you ensure that your customers follow the guidelines that you create? Because, you know, it's like you don't have much control over it. It just goes out there in the open and people can interpret it and use it in many different ways.
That all depends on the kind of customer. We have different teams using us in many different use cases. Sometimes they are just on their own. We give them components and they build everything they want because they are not constrained by the guidelines. However, for some services where it's important to be consistent because user goes from one page to another, built by different teams, but they still need to have this feeling that, yeah, we're still on the same service. In this case, we try to enforce it by doing some design review, giving them feedback, and trying to make sure that like all code that goes to production gets reviewed properly.
Wow, I think it still like happens at such scale because Amazon is such a huge company. I cannot really imagine how all of these feedback loops happen behind the scenes.
Like if to put long story short, there is a checklist, and if you build a feature, you go and establish a process, which includes feedback as a kind of a required part.
Makes sense. I love checklists. I use them in my design process myself. Okay, so now onto the questions that we have on Slido. We have a question from Olga. Sage, how long does it take you on average to build a component, roughly?
Yeah, I think like as a developer, one of the things with I think we can all agree on that. We're really bad at estimating how long it takes to build something, right? Like you can say, like I can tell you it takes 1 week, and then it's gonna take me a whole month to finish it up, and that depends on the complexity of the component. Again, obviously, you'll feel really weird if I told you it took me 1 week to build a button component. So, like, it depends on the complexity and the logic of that component. So, on average, it'd be like a very simple component, like a button that doesn't have like any interactive states. It's just purely UI. Maybe you might spend some time to think about how do I want to compose the different variants of the button when it has an icon to the start and at the end. Like you just want to think about that a bit more deeply, and that should probably not take so much time. And by so much time, I mean like working about. I mean just taking a few days off to think about the API and just writing the code of that API. I think we're really bad at estimating time, but like from my experience, I think I built like a ton of components, so I think my estimates would be like very unfair for most people like out there. So I would rather not. I would defer to giving an estimate of how long it takes, but I'd say it typically takes like somewhere between a few hours to 3 to 4 days for like fairly okay components that doesn't have so much logic. But as it gets more complex and interactive, like menus and like tabs and like let's see, accordion, custom selects, like all of those really gangster components, those will take quite some time to actually like figure out. And depending on like, if you're working in a company to work on a design system, most of the time you have a goal to meet the accessibility criteria, whether it's a strict one or it's like a fairly loose success criteria. For the fairly loose type, you probably be able to knock it off in a few days. But when it gets like you want to achieve like the highest standards, then you're probably looking at weeks, if not months, to finish that.
I also liked how you kind of gave us a preview into your process a little bit. You mentioned that you conducted your own Dribble research. I love doing that once in a while myself. And you also looked at different components from different design systems. I also appreciated it how you're trying to kind of get an understanding of what the industry's standard is. And I think this is just kind of building on top of it. This what bothers me a lot is that we don't have one unified industry standard. And how do you come up, how do you derive a vocabulary or something that's universally accepted and understood in this environment where people might call different things different ways?
Yeah.
And then it also creates like a lot of friction in your team communication because you have to come up with your own internal vocabulary for things. So like, do you have any insights for us about this as well?
Yeah, for sure, I do. I think most of the time I tend to sort of use this idea of like pattern recognition, where you sort of do a lot of intensive research into like other existing, not just other existing libraries, quote unquote, like other React libraries. So like sometimes I mean, I had a conversation with my friend. I mentioned that he asked really similar questions, and I said like sometimes I go as far as go look at Swift UI code or like Flutter.dev and just like check like other mobile platforms. They also have APIs, API specs. And like one of the things I always assume is that people that build frameworks like this have spent like tons of hours and if not months and years trying to figure out like the best API for their components. So instead of me doing all of the work myself to start to do research and showing my team here and there, I just go find the best in class API from companies like this, and then I look at design systems from like huge corporations as well, because they always have dedicated people that spend time on these things. So just learn from other people, get ideas, think about them. I would say like it doesn't mean you have to do like use any one specifically, but get all the ideas and then just make your choice. But then when presenting ideas of like what name you should use or what component it should be, you want to present options to your team. Not like, I mean, I've done my research and this is the best one. No, it has to be the best one. But it's more like these are the ideas that I've sort of gathered so far, and these are the APIs I'm turning towards. And I always find it works like 100% of the time. People just sort of tend towards one of them or one of the two ideas I present, and it just works. Yeah.
Oh yeah, sorry, that's just so much to unpack. I just wish we had one universal place with all the standards that are just accepted and understood by everyone. Boris, do you have anything to add to this? I don't know whether you're actually like working with your team on defining the vocabulary, or you're just using, but whenever it comes to communication, like what are your struggles, and how do you facilitate this communication that's like understood throughout your team?
That's a great question, because we always have had this difficulty in the past, where we have a request for a component, let's build this. This is how it's looking like. But then, when we show a picture of it, different people give it a different name. And then we need somehow to unify. We need to make sure that when we create documentation where it says a button or an input, everybody has the same image, the same expectations from the name. So yeah, sometimes it's getting very tricky. Usually we try to look around and other design systems to see what name is more prominent, and then we make our decision based on that. Or sometimes we also try to give different name based on like constraints. If a popular component do something different, that our component will not.
Yeah, it's interesting.
Definitely a
It's
pain
interesting
point.
actually. Yeah, so I mean, it's really interesting because one of the things that came to mind while Boris was talking is like, I think most of the time it sort of narrows down to the design team. So typically, so if you're working in the design system team, you usually have like a product designer dedicated to shaping the UI and how it looks and feels. I think that the naming convention from the design area typically influences the development as well in some way. And like one of the challenges I've seen in the past is a designer giving a component the wrong name and literally being like very strict and rigid that, hey, this is the name we want to call it, and that's it. I mean, but I find that like when a designer has like a better knowledge of the medium is designing or he or she is designing for, I find that they tend to, like, designers are way better at naming stuff or naming components, even more than developers, at least in my experience. So for a more slightly organized designer who takes the time and extra pain to rename their layers and organize everything properly, I think I found that a whole pleasure to work with, but that's not too many people, I assume.
I also know about the initiative from Microsoft Edge team. These folks try to create some sort of an inventory of the namings. I don't have it in hand, but I could look it after, where they try to analyze what is currently existing out there, and they try to create some sort of components taxonomy, trying to understand and unify the people. So I really support their idea and initiative.
Yeah, if you find a link, drop that in the YouTube channel, or we can share it later. All right, so the next question is from Nasya. I hope I'm not butchering this name. Apologies if I do. Could you please explain the advantage of replicating the native browser behavior with all of this React code? I believe this is to Sage.
I believe that too. I think one of the things that one of the best ways I can reply this is like, I really wish the browser had all of this. Like, I prefer 100% to use the platform instead of having to reinvent the wheel like every time. Right. So the reason why these specs are living and alive today is because the platform does not have that. Right. So I mean, I think there's currently like an ongoing conversation in the Chrome developer team to actually add like components like the menu, pop-ups, and like once these components come to the platform, I'll probably be the happiest person on earth because I don't have to maintain all of this like React code again. I just want all of that to go and just use the platform itself. So I wouldn't say there's an advantage. The current disadvantage that we see is these components don't exactly exist. So people have to either just build stuff on their own, or if they care about accessibility, go through the accessibility spec and try to get it like working almost one-to-one, and then just use that for their own, for their own product. So this is the reason most of these components don't exist in the platform. And even if they do, some of these components are pretty hard to style. The classic one is the select component. And like where it gets super tricky is if you tell a designer to work on a select component, they're gonna go all fancy and design like a very nice, sleek select component. But then when you come to the platform, you find like you cannot even style or change the background or font of like this select menu here, and you have to most likely write your own select components from scratch again. So these are the pain that we UI engineers have to go through when a designer is just moving some rectangles in Figma and then just put some text and then that's it. But then for the UI engineer,
Ouch.
it takes like days and months and blood, sweat, and tears to actually get the component working, especially the behavior of that component working correctly.
Makes sense. All right, so the next question is from Nigel, and it is to Boris. What are some of the adoption challenges you faced from teams? For example, those who didn't have the time or people to adopt the system, or who is busy solving product features and give low priority to adoption?
That's a great question. We did have some challenges. Usually, we try to show the benefits of the system. We show how it's better to have a standard table that build their own. For example, if they have a custom table, all bugs that will be found and reported for this table will be on the team to fix. When they use a shared table, they don't need to fix them. They report it back to us, and it's our responsibility to provide a fix. This way, they could somehow get off the burden of maintaining the component. And usually people give us later, after they migrated, they tell us nice stories, how much custom code and custom test cases, regressions, they could remove from their code base because now they could rely on our component. And usually this works as a motivator for the teams, and they adopt our components when they exist.
Do you have other stories that are like not success stories, where people were frustrated with some, I don't know, lack of documentation or guidelines or anything? It's always great to learn also from failures.
Usually we try act on such reports quickly. Like if sometimes it happens when some documentation is vague. For example, we did not document a use case properly and people misinterpreted it differently. In this case, we usually try to identify these cases, provide the documentation addition. We have many design articles, but they are not set in stone. We try to iterate based on see how people use these articles, how they understand them. So we try to go back to articles and rewrite them sometimes where we see that the understanding was different than we expected.
Cool. And I think we have one last comment from Boris. I believe this is you, Boris, unless we have other Borises in the stream, which would be amazing. Thank you for the talk, Sage. How was your experience with XState in general?
Yeah, that's interesting. For those that are not familiar, XState is mostly like the library you use to write state machines, like I described. It's just a popular library in the JavaScript ecosystem. My experience with it, I think, has been really good. I'd say. I think the documentation is also good. It just can get like quite like tedious to wrap your head around if you're coming from a more Redux or use state land. I mean, moving to XState or writing state machines might feel a little bit tedious starting out. But one of the things I do to help myself is to just draw circle diagrams. Just go like open, like grab a pen and paper and just draw circles. Like when you click on this, it goes here to this one. And when you make it like super easy for yourself, like you can just draw a flow chart. I mean, if you can draw a flow chart to describe something, there's a high chance you can most likely model that in code, whether it's state machines or not, right? So XState has been a pleasure to work with. But for Chakra UI, I found that it's quite a big library. Like the current version is quite a lot to embed into Chakra UI itself because we have close to 2.9 million people using Chakra UI at the moment, at least that we know of as public. So we cannot afford to murder all of those people by taking a huge library and putting it into Chakra UI. So that's the only challenge I've seen so far. I know they're currently working to make it like maybe smaller, or like you can sort of opt into the feature that you want. But what we have done right now is to just make our own little X state that is super small, but that uses the same ideas as X state, and then we just try to work with that instead.
Yeah, I understand it. What would be the case where you will not use a state machine? Like, is there possible?
Yeah, I'd say maybe I want to design a simple checkbox. It's like a state machine for that is more like using a hammer to kill a mosquito. Typically, I don't want to like go that huge. So it's mostly like I think for fairly simple use cases, like you don't need that. You can just write a very simple code, like use state, and like get done with that. But when it starts to go like, I think when you want to build an application that feels like it's initially simple but might get complex over time, or when you have some really complex interaction for your application, whether it's for your component or a whole product, there's a lot of advantage to modeling this as state machines. So you can easily visualize them, communicate them. I can literally take the visualization from Excel and print it out to the team and say, don't worry about the code, just take a look at this flowchart. Does this make sense for you? And like if people can say, yes, this makes sense, and someone can say, no, what if you change this arrow to this one instead? It makes more sense. The moment you can take people thinking outside the code, and they just like draw flowcharts and connecting like logic together on paper, I think I'd love to see a team like that, so that like writing the code is pretty much a pleasure with state machines. But if you have to write the code from a flowchart without state machines, there's gonna be a mess of if else and use effects in your code that literally drive you nuts if you're not careful. That's my thought. But it's actually been good so far, I think.
I agree with you. It's very good for the use cases where like you have super complex states and difficult transitions.
Yeah, awesome.
Not to put you under a spotlight, Sage, but this is your last chance if you have any questions to Boris, or otherwise we're going to wrap up.
Yeah. I think the question I have to Boris is so currently we're having to think about moving Chakra UI to support like multiple frameworks, just like AWS Design System. We're currently like even struggling with like going from React and supporting Vue as well. Like that process is not as smooth as I'd like it to be. So I'm curious, like what advice or what thoughts do you have on like expanding or going from a single framework like React to expanding that across multiple frameworks like Vue or even Ember.js or things like that? Like, what approach do you currently take within your team?
The biggest learning we've got in this process that frameworks are not only about components. They are not only about some blocks of UI that you combine together. There are also some invisible bits. Like, for example, when we talk about React, there is context, there are hooks, there is suspense API, and there will be more. And all of them are not inside the components. And when you build a framework agnostic thingy, you cannot leverage them properly. You have to forget that they exist. And this limits abilities. So it's always a difficult trade-off. If you would like to go into a multi-framework approach, and then you will not be able to use these features. Or you believe that multi-framework is useful, you really would like to support more teams, but then you will have to limit your freedom, your liberty in what APIs from a framework you will have to use. So it's a difficult trade-off, and there is no good answer one for everyone.
Yeah, I think that's such an awesome answer. I mean, in summary, I guess it's mostly like you pay a price for doing that kind of thing. Awesome.
So yeah, I think missing context is what was called out often for our poly-framework components, that you would like to use. Even if you don't use context directly, many libraries in the ecosystem do use. And when it doesn't propagate through multi-framework components, customers get very surprised. So it's very important to still be a good friend for the framework that you are building for.
Yeah, that's such a good advice. Thank you.
You guys should rip off on some of these ideas together. Awesome. So I think this wraps up our Q&A. And I will hand over to Angie to close the session.
All right. I think, I hope we've answered all of your questions, and you also enjoyed the talks for this round. Please reach out to us if you want to be part of the meetups with the talk or part of the organizing team. And I'm copy pasting the link where you can find all our content information. And we hope to see all of you next time for our future events as well. And until there, please take care and bye-bye.
Bye, everyone.